In this video, we'll revisit the tangent problem. So let's see that we're starting with a function, right? Y equal to f of x. So that's our function. So every function, if you put all the ordered pairs x, y, such that y is f of x, right? Ordered pairs satisfy the equation. You get a graph in the xy plane. So this is the graph of this function, right? So if you have a graph, you can fix one of the points, right? We pick a p here, which is a f of a, right? So that's a point in our graph, right? If you try to visualize it, what you have here is starting from uh, this xy plane, right? And you sketch a curve, which is our graph of this function. This is our c here, which is also called y equal to f of x. So that's our function, right? Then you fix one point. You fix a point to be p. X value is a here. So y value is a f of a, right? Now we want to know what's the equation of the tangent line, right? We are looking for the equation of the tangent line passing through P. So that's what we want to, the line equation. So let's call that L here, right? How do we do that, right? How do we do that? So we say that equation of L, which is the tangent line and to C at P, right? And so this is given by, we can use a point slope form, which is y minus f of a here equal to, we can call the slope to be m0, right? M0 is slope, x minus a here, right? Where m0 is the slope of L, right? So how do we get our L, right? By our discussion before, we just starting from arbitrary points, we call that, let's use green, orange here, right? This is our Q here. Q is given by x, f of x, right? You connect PQ, you get a secant line, right? So as Q getting closer and closer to P, so the secant line will go getting closer and closer to our tangent line, right? So we know that we call that M PQ is the slope of PQ, right? By our definition of slope, we know that MPQ is difference of y value over difference of x value, so which is f of x minus f of a over x minus, right? By our discussion, we know that m0 equal to the limit as x goes to a pq, right? And so this is equal to as x goes to a, what's that? F of x minus f of a over x minus a, right? Let's see. So this is basically how do we solve the tangent problem, right? Using our definition of limit, we can do that. Let's see a very quick example here. In this example, our function is given by y equal to 3 over x, right? So that's a curve or function. we give a point P to be 3, 1, right? What we want to do here is we want to find we can find equation of the tangent line to the curve y equal to x over 3 at x 3 over x, right, at the point p 3, 1, right? So basically all you want to do is you need to figure out the slope, right? So the slope m0, right? So let m0 be the slope m0 to be the slope, right? Then m0 is what? M0 by our discussion here is as x goes to 1 here because our value of a here is 1, right? F of x minus f of x is 3 over x minus 3 over 1 over x minus 3. Sorry, x goes 3, right? Because our x value here is a is 3 here, right? So how do we evaluate this limit, right? How do we do that? We have many different tricks, right? And for sure, you cannot plug in 3 because if you plug in 3, you get 0 in the denominator, right? We want to cancel the factor which make the denominator to be 0, which is x minus 3. So we don't have many other tricks, just use algebra, right? X goes to 3, you get x common factor on the numerator, you get 3 minus 3x. X is 3, this is 3 here, right? 3 over 3, which is 1. So this is 3x 3 times 3. Okay, so times 3 here, this is times 3 here, right? Over x minus 3, right? And so this is equal to what? This is equal to as x goes to 3 here, and try to arrange our denominator, you get 1 over 3x times 3 times 3 minus x over x minus 3, right? We know that you can cancel x minus 3 by put a negative 1 on the numerator. So the answer is negative 1/3, right? Then you can plug in 3 because after you cancel the 0 factor, you can plug in 3, right? So equation of the tangent line is what? Is y minus 1 equal to negative 1 over 3 x minus 3. So that's how do we apply our definition of limit to revisit our tangent problem.